Simplifying radicals. You first learned how to simplify radicals in Algebra 1, so we're going to do a quick review of how to do that. In the box, you'll find a list of common perfect squares. And just to review, a perfect square is when you multiply a number by itself. So 4 is equal to 2 times 2. 9 is equal to 3 times 3, and so on throughout this whole list. There are many more though. Knowing our perfect squares, that's going to help you simplify your radicals a lot quicker. So just try your best to memorize these and keep them in mind. So first I'm going to try and take the square root of 48. Now if I were to plug that in my calculator, that is not a perfect square. That's not on my list. So I can't get a number. But I am going to simplify it so the number underneath the square root sign is smaller. And that's the goal. I'm trying to get the smallest number possible underneath the square root sign. So first I'm going to break down 48. So I'm thinking, what times what gives me 48? Well, I can say 2 times 24 will give me 48. I then cross out the 48 because it is now broken into 2 and 24. 2 cannot go any smaller, but 24 can be broken down to 2 times 12. And then I'm going to cross out 24. And then 12 can be broken down to 2 times 6, cross out 12. 6 can be broken down to 2 times 3. I'm going to cross out 6. Now because I'm taking a square root, I'm going to circle same numbers in groups of 2. So I have a group of two same numbers here, and I have another group of 2 same numbers. So these groups are now getting moved to the outside. And what happens is the group turns into one number. So I have one group of 2's on the outside times another group of 2's on the outside. And I still have the square root of this lonely 3 that is not circled. That is left underneath my square root sign. My last step is to simplify the outside. So I have 2 times 2, which gives me 4 square root 3. And that is my answer. That is my simplified version of the square root of 48. So in a calculator, if you were to do the square root of 48, hit enter, you'd get a decimal. Then if you were to type in 4 square root of 3, hit enter, you would get that same decimal. So all we're doing is making it smaller. We're simplifying it. All right, we're going to do another example. So now I'm looking at the square root of 200. That's not a perfect square, so I'm going to break it down. 200 is the same as 2 times 100. Cross out 200. 2 cannot go any smaller. But I do notice that 100 is on my list. That's a perfect square of 10 times 10. So I don't have to go through and go down 2 times 50, 2 and 25. I can just break this 100 to 10 times 10. And there's a pair of my numbers. So the 10s go to the outside. We have 10 square root 2. And you could have broken down 100 differently if you didn't recognize it was a perfect square. It just would have taken you a little bit longer. We are also going to see radicals that look like this, where we have a number in front already. So 3 square root of 8. I'm going to see, can I make 8 smaller? Well, 8 can be broken down to 2 times 4. And then 4 is one of my perfect squares that is broken down to 2 times 2. I'm going to cross out the 8 and cross out the 4 because I broke them down. So I've now found a group of 2's. They are going to the outside. So I have 2 on the outside times the 3 that is already there, square root, and I still have a 2 left over. Then all that's left is to simplify my outside. So 2 times 3 is 6, and we still have that square root 2. And that is our simplified version. We're also going to see in Algebra 2 our radicals written like this. So -5 plus or minus square root of 48. We're still going to go through this the same that we have been. So 48, I'm going to break that down, and let's pick different numbers this time. I'm going to use 4 and 12. And then 4 I can break down to 2 and 2. Cross out my 4. 12 I can break down to 2 and 6. Cross out my 12. 6 I can break down to 2 and 3. Cross out my 6. All right, then I'm going to circle my groups. So I have 2 2s and 2 2s. Now these groups are just going in front of the square root sign. They are not going in front of everything. That's the big difference here. So for this example, I still have the -5 plus or minus, and then I have my 2 groups. I have 2 times 2 in the front, square root, I still have that 3 left over. Then if I were to simplify, I have 2 times 2, and that turns into 4. Still have the square root of 3, and then we just carry down the -5 plus or minus. And that would be our answer. All right, and we've got 3 more examples of things you will see in Algebra 2 with radicals. Okay, so now we have 10 plus or minus square root of 44 all over 2. I'm first going to break down this square root of 44. And that's going to get broken down to 4 times 11. 4 is my perfect square of 2 times 2. So there's my group. So remember, that's just going in the front of the square root sign. So if I'm going to rewrite this, I have 10 plus or minus. I now have a 2 square root 11 is left over all over 2. Because we have a fraction, I have to check, can everything be divided by this bottom number? So can I do 10 divided by 2? Yes. With this, we only care about the number in the front. So can I do 2 divided by 2? Let me redraw that a little bit. And yes, I can. So we'll do 10 divided by 2 gives me 5, plus or minus 2 divided by 2 gives me 1, and then we still have that square root of 11. This is perfectly fine to write your answer like this. You'll just most likely see it written as 5 plus or minus square root of 11, because we don't write imaginary ones in front. So either one of these will work. All right, next example, I have 3 times the square root, or I'm sorry, 3 divided by the square root of 2. You're not allowed to have a square root sign on the bottom. So what we do is we're going to actually multiply this by a fraction. And whatever square root's on the bottom, that's what we're going to multiply by. So we're going to multiply by a square root of 2 on the bottom, and then that same thing to the top. And when we multiply fractions, we multiply straight across. All right, so what happens is the bottom becomes square root of 2 times 2. Because they are both under that square root sign, I can put them both under the square root sign. the top just becomes 3 on the outside, square root of 2. Now let's think back. This whole time we've been simplifying and we've been circling our groups of 2. So we have 2 2's here. They're going to go to the outside. So now on the bottom of my new fraction, I have a 2 on the outside, and I have nothing left. So this just turns into 2. And then on the top, we have 3 times the square root of 2. 3 cannot be divided by 2, so that is our answer. A shortcut is that on the bottom of these fractions, because I did a square root of 2 times the exact same number, square root of 2, it just becomes that number. Now our last example, square root of an entire fraction of 6 over 9. You also see radicals like this with fractions. Easiest thing to do is to break it up. So we're going to say the square root of 6 divided by the square root of 9. Now what this does is this creates a square root sign at the bottom. And we could multiply it like we just did, but this is special because 9 is a perfect square. So 9 is broken down to 3 times 3. So really the bottom of our fraction becomes 3. The top is still square root of 6. To the side I'm going to see, can the square root of 6 be simplified? So 3 times 2. Nope, I can't take any numbers to the outside. So that is my final answer. So that was a quick review of how to simplify radicals with a little bit of what you'll see in Algebra 2. So if you have any questions, just make sure you reach out to me.